So now the second question. Alright. Describe how the volume of a regular solid can be determined. So this question is more of a conceptual question. Now for this one, okay, it's a regular solid. It's not a liquid, but they're asking in terms of volume. So the technique commonly used, as they'll describe most likely in the answer here, is through volume displacement. So usually if you want to find, you know how you can see like let's say like a rock or something, right? I don't know why I do it like that, but a rock. And then they'll say like this rock is like 34 grams, or like they'll actually put 34 volume sometime. I mean 34 milliliters, something like this. The reason why they can even say that is because most of the times what they use is a technique called volume displacement, and this is key because this only applies to, you know, solids that do not dissolve in that liquid. So what it does, they usually just get a beaker or a glass with indicated markers on it. All right, they fill it with water, and then they throw the solid in. Okay, and then there's a change once that solid goes in, right? The displacement in the water, this volume displacement, okay, this amount right here is what they use to determine the volume of an irregular solid. So let's say this marker was at let's say 4 mil, and then the volume was placed at like 4.5 mil. The volume of this irregular solid would be 0.5 mils. So that is the trick here in regards to this, at least in describing it, because what you have to understand is that the whole concept of, you know, matter can't be created, destroyed. It's just transferred, whether through energy. But point being is, like, because it takes up so much space in terms of the surface area, that space now has to be accounted for by the water level rising, and hence how we get this. Now this does only work specifically, as I said, for solids that do not dissolve, and also solids that are not buoyant. Depending on the buoyancy, it has to be fully submerged. If it's not fully submerged, you can't really say, like for example ice, it's hard to say the volume of that solid because it usually floats on top of the water. But for heavier things that are more dense, like metals, coins, throw a bunch of coins into water, actually, it's a cool way to find out how many coins you have in regards to milliliters. So yeah, that's for that question here. Let's see what they say. Cubic meter. And exactly. So this here, it's actually pretty cool in terms of how they mentioned it, because the grams can be converted to, if I remember correctly, like grams and mil are quite similar, and in terms of the cubic meter, so that's meter squared. I believe that's usually compared to kilograms and liters, those three. So here I believe it would be usually meter to meter squared, but no one really talks about that. I focus more on these. These three are usually synonymous because the surface area can be turned to the liters, and the liters can be turned to kilograms as well. Kind of like just that consistency usually, but this, in this specific situation, is just how much the water level rises through volume displacement. So let's see, and make sure you have indicated markings to actually, you know, figure out how much volume it was. Whoops, we don't want that. This is correct. So there we go. All right, so now question 3.